This is our third video on dynamics for physics classroom, and I made two originally, but the students were asking for more practice questions, so I just added some more practice questions so you would be feeling better and comfortable about the topic before you take your assessments. So in this question it says, what will happen to the airplane that has all acting on it forces balanced? So if all the forces balanced from your previous videos, that means that there is no acceleration. The net force is equal to ma, so F net is equal to ma, and if all the sum of all the forces is equal to 0, then acceleration is equal to 0. And what about the car with the balanced forces? So if this car is driven with the balanced forces, again, this car is not going to accelerate. The vertical forces cancel each other. That's the normal force and the force of gravity. And then the person is pushing on the pedal, so the car is moving forward. But the force that the person is applying in this direction is equal to the friction force. So when those two forces cancel each other, when the applied force is equal to the friction force, the car is not going to accelerate, so that the forces are balanced. In this question, they say calculate the acceleration of, in my problems in the classroom, I would usually write everything that is given. So here you have the airplane mass. Before takeoff, if the thrust on the engine is 500 newtons. So from the information that is given over here, I have the mass, which is 2,000 kilogram. And I have the force acting, which is 500 newtons. And they ask me to find the acceleration. So the net force, second Newton's law, the net force, or the sum of all the forces acting on the object, always equal to ma. And again, if the forces cancel each other, then acceleration is equal to 0. Does not mean the object is not moving, it just doesn't accelerate. So the force in this case is equal to 500. The mass is 2,000. I can cancel 100 and 100 from both sides, so that gives me acceleration is 5 over 20, which is 1/4 or 0.25 meters per second squared. Also, when you do my lessons, and if you find a lot of questions that you don't understand, or you try to do practice questions and then you don't see the answers, or you don't come up with the right answers, take pictures of those problems and send them to me so I can respond to you with the videos or explanation. That's what I want to do to help you to learn. So for the next question, they say that a 3-kilogram ball, so mass is given. So maybe I'm going to write the mass right away. The mass is given 3 kilogram. Is in the free fall on the moon. It is pulled down with an unbalanced force of 4.8 newtons. So that is the force of gravity that is acting on the ball when it's falling down on the moon. So that's 4.8 newtons. And they ask you, what is the acceleration of the free fall acceleration due to gravity? So in this case, my unbalanced force of gravity, or that's my net force, because there's no other forces acting when the ball is falling down on another planet or on the moon, equals to ma. And in my case, a is acceleration due to gravity, so I can also say mg. So I could say the net force in this case is equal to mg, and that is 4.8 equals to the mass times acceleration due to gravity. So acceleration due to gravity is 1.6 meters per second squared on the moon. Also, this is a good part to always remember, and it's one of the conceptual videos. The mass of the object does not change when you take it to different planets. So the force of gravity acting on Earth, so I'm going to write E for Earth, is mg. Acceleration due to gravity on Earth is 10, so the force of gravity on Earth would be 30 newtons. And the force of gravity on the moon is mass times g, but g changed. Mass does not change of the ball, g changed, and that gives you 4.8 newtons. So the same ball will weigh less on the moon than on Earth, but its mass does not change. Its mass stays the same. because mass is just how much stuff is in an object. So how much stuff did not change. The acceleration due to gravity changed, depending on the different planet. Mass and size. So the larger the mass is, the more gravitational pull, and the black holes have a lot of mass but different smaller radius, and that causes even stronger pull. Here's the next question, and it says an elevator rising at endless miners in a mine shaft. Suppose the elevator carries a group of miners down the shaft. If the unbalanced force on the cage is 60 newtons and the mass of the loaded cage is 400 kilograms, what is the acceleration? So we have the net force acting is unbalanced force, I mean net force is 60, and equals to the mass times acceleration. So that is 400 is the mass and acceleration. Divide by 10, divide by 10. So acceleration is equal to 40 divided by 6. That's the same as 20 divided by 3, or 667 meters per second squared. In this question number 10, they say that Eduardo applies 4 newtons force to the right to a 0.5 kilogram book to accelerate across the tabletop. The coefficient of friction between the book and the table is, and it is kinetic friction because it is sliding. So when the object is sliding, it's kinetic friction. And if you have something on an incline and it's not sliding yet, that is static friction. So when you walk on the floor, you're not sliding because there is static friction. But if you're sliding on the floor, then that is the coefficient of kinetic friction. So this one is given kinetic friction because the book is going to be sliding. And you have to determine acceleration of the book if the person keeps applying the same force, and how far will it travel in 3 seconds if it started from rest. So the information that is given, the force that is applied, and the mass of the book. And again, I do F net is equal to MA. And in our case, we also have friction. So the net force is not just applied force. The person applies 4 newtons, but there is also friction. So your F net has 2 forces. One is the one that is the friction. So this one I'm going to say friction. And then, so this one is the friction. And this one is the applied force. So this is applied force. And the other one is the friction force. And they are against each other. So applied force minus the friction force is equal to mass times acceleration. So applied force is 4, and the friction force has the formula as well. So the friction force is equal to mu times the normal force. And in this case, your normal force is equal to, so the normal is the up force, is equal to the force of gravity because they both cancel each other. So in this case, you have the normal force is mg, so you have mu mg. And because we don't deal with inclines in regular physics classroom, so your n is always going to be mg. So I have 4 minus mu times mg equals to mass times acceleration. I'm going to keep my force, applied force, just F for now, so I don't have to plug in numbers yet. So now when I have the equation, I can plug in the numbers. I have 4 minus mu, they give me 0.4. The mass is 0.5. And acceleration is 10, and equals to the mass, which is 0.5 times acceleration. So here I have, if I times 0.4 by 10, that is 4, and then times 0.5 is 2. So I have 4 minus 2 gives me 2.5 a. So acceleration is equal to 4 meters per second squared. And if an object started from rest, then I can find the final velocity is equal to initial velocity plus the acceleration times the time. So the final velocity is equal to initial plus the acceleration times the time, they say 3 seconds. So the final velocity is equal to 12 meters per second. And the distance is equal to average velocity times the time. So the distance is 6 times 3, which is 18 meters. In this question, they say a freight train slows down as it approaches the train yard. A force of, and this looks like it's the net force, is required to provide an acceleration of, so they give you acceleration with what is the train, and you have to figure out the train's mass. So for the first part, to figure out the train's mass, I have the net force again is equal to mass times acceleration. The net force is negative 410 to the 6. It's a stopping force, so that's a negative 1. And you have mass times acceleration is slowing down, so that's negative 0.2. So the mass of the train is equal to, so I'm gonna divide by 0.2 both sides, and that gives me 10 to the 6 kilogram. And the next question, they ask you, if the train was originally moving at 10 meters per second, how long will it take for it to stop? So the final velocity again is equal to initial velocity plus the acceleration times the time. So I can plug in the numbers, and I have final velocity equals to initial velocity plus the acceleration, which is negative 0.2 times the time. So the time is equal to negative 10 divided by negative 0.2, which is 50 seconds. And then for the next part, they ask you, let's do it in yellow. For the next part, they ask you the distance it travels before it stops. So the distance is average velocity times time. So initial velocity is 10, and the final velocity is 0, so that's 5, and the time is 50 seconds. So that's 250 meters. For this next question, they say that the same 12 Newton force is applied to two different objects. One has a mass of 3 kilogram and the other one is 4 kilogram. If both objects started from rest, what will be their speed in 5 seconds? So if I have two objects, 1 and 2, and one is 3 kilogram, it is 3 kilogram, and the other one is 4 kilogram, and the same 12 Newton force is applied, and they don't say anything about the friction. So here is 12 newtons and here is 12 newtons. Then F is equal to ma. I'm using second Newton's law. F is equal to ma. So the force is 12, mass is 3, so acceleration here is going to be 4 meters per second squared, and acceleration here is going to be 3 meters per second squared. If they both started with 0 meters per second initial velocity, and again 0 meters per second initial velocity, then the final velocity in 5 seconds, so you use the final velocity formula, so the final velocity is equal to initial velocity plus the acceleration times the time. So initial velocity is 0, acceleration is 4, time is 5 seconds, so that's going to be 20 meters per second. So the distance here is traveled, average velocity times the time, and the distance is 10, average is 10 times 5 seconds gives me 50 meters. And the distance here, initial velocity is 0, in 5 seconds it's going to be 15 meters per second. I'm using the same formula, final velocity is equal to initial velocity plus acceleration times the time. Then the distance again is equal to average velocity times the time. In this case, average velocity is 15 over 2 times 5 time. So I get 75 divided by 2, which is 37.5 meters. So you see the same force was acting on two different masses, and the one that is more massive has more inertia. So it doesn't accelerate as fast as the one that has less mass. So the object with less mass will travel more distance under the same conditions of the same force as the other mass. And in this question, they say a 1,000 kilogram car, so that is the mass. Sometimes they can say 1,000 Newton car. So if they say 1,000 Newton car, that means 1,000 is the weight of the car. And the weight means mg. So if they told you that the 1,000 Newton car, that means they tell you mg. So the mass in this case is going to be 100 kilogram. But in this problem, they say it is 1,000 kilogram car. So they give you the mass of the car. And it is moving with initial velocity of 20 meters per second. What force should be applied in order to stop the car in 5 seconds? So I have initial velocity, final velocity, and the time. I can use the acceleration to find the time. So acceleration is equal to change of the velocity over the time. So final velocity is 0, initial velocity is 20, and the time is 5 seconds. So that gives me -4 meters per second squared. And they ask you what force, and the force is equal to mass times acceleration. So the net force needed to stop the car is mass times acceleration. Mass is 1,000 and acceleration is -4. So that's -4 kilonewtons. 1,000 newtons. Kilo stands for 1,000. Here's another question where they say that 500 kilogram bike, so again they give you the mass, not the weight. 500 kilogram bike was moving with initial velocity of 15 meters per second, and what force should be applied in order to stop the bike in 5 seconds. So because again I have initial and the final velocity, I can have change of the velocity over the time to find the acceleration. So that's 0 minus 15, initial velocity is 15 divided by 5, gives me -3 meters per second squared. And force is equal to mass times acceleration. The mass is 500 times -3 gives me 1.5 kilonewtons. It's -1,500, so it's -1,500, or -1.5 times 1,000. Kilo stands for 1,000 again, newtons. For the next question, they say a 4 kilogram rock, so again they tell you the mass of the rock, falls the distance of 125 meters from the mountain into the ocean. What is the rock's velocity when it hits the water? So you have a mountain right here, and you have the water, and then the rock is splashing into the water, and so they show that it splashes. And the rock, the mass is given and the distance is given. Because I know this height, I can find the final velocity. So I can find this final velocity, it's a free fall, so I can use the DA formula. So for A, my final velocity is equal to the square root of 2 acceleration times the distance, and initial velocity is 0. So I have the square root of 2 times 10, and the height is 125. So that gives me 50 meters per second. Then the next question they ask you, if the rock stops 15 meters below the ocean, find the time it takes to stop. So if the rock stops 15 meters below the ocean, I'm going to use the distance because they give me the distance. And that is average velocity times the time. So to find the time, I need the distance, which is 15, divided by the average velocity, which is 25. Because it enters the water with 50 meters per second, and then it stops underneath the water. So that's 0. So that gives me 3/5, 4.6 seconds. So that's how long it will take to stop. So that is for B. For C, what is the deceleration? So acceleration is equal to change of the velocity over the time. My final velocity is 0, it stops underneath the water, but it enters at 50 meters per second. And I'm going to divide it by 0.6, the time. So that's the same as 500 divided by 6, or 250 divided by 3, which gives you 86.7 meters per second squared. And it is negative because it's deceleration, so it's negative. And it's 83.3 meters per second, so negative 83.3 meters per second. And then the last one is, what is the net force exerted by the ocean on the rock? So if you're looking for the net force, it's again mass times acceleration. I just found acceleration is negative 83.3. So the mass is 4 times 250 over 3, and it's a negative. So I have 1000 over 3, which is negative 333.3 newtons. So that's the force exerted by the water on the rock to stop it. Let's look at this bucket question. A 50-kilogram bucket is being lifted by a rope. If it starts at rest and after being lifted 3 meters, it is moving at 3 meters per second, with what constant acceleration and what tension in the rope there is, right? So I'm gonna write down everything that's given again. So 50 kilogram, distance, and final velocity, but initial velocity 0. Because I have the distance and I have the average velocity, I can find the time. So the time is equal to distance is 3 meters, and initial velocity is 0, but the final is 3, so the average is 1.5. So it's going to take 2 seconds to get to this final velocity. So now I can find acceleration. Acceleration is change of the velocity over the time. Initial velocity is 0, final is 3, so I have final minus initial, divided by the time, that gives me 1.5 meters per second squared. And then to find the tension, here's the tricky part. So if you have a bucket, let's write the forces acting on the bucket. You have mg, you have the tension, and now we found acceleration. So I'm going to write Newton's second law. So I have F net is equal to ma. Net is how many forces acting on the bucket. Well, the tension, I'm going to say it's positive because it's up, and negative is mg because it's down. And in my case, acceleration is up, so it stays positive. So the tension is equal to mg plus ma. The mass of the bucket is 50 kilogram times 10, so mg will give me 500, plus 50 times the acceleration, which is 1.5. So the tension is equal to 500 plus 75. So the tension is 575 newtons. For the next question, they say that you push 50 kilogram wooden block, so the mass is given 25 kilogram wooden block, so the mass is given 25. Across the wooden floor with a constant speed of 1 meter per second, how much force do you exert on the box if coefficient of friction is given? So I have the mass, I have constant velocity, and I have coefficient of friction. So I'm going to write my equation, but I need for that forces. So you apply some force F, and the force of friction is in the opposite direction, and the mass is given. So I have the net force is equal to ma, so F net is equal to ma, and your net force is the force minus the friction force is equal to mass times acceleration. The force is not, it's constant velocity, so there is no acceleration. So that means the applied force must be equal to the friction force if there is no acceleration. That means the force that you need to apply is equal to mu times n, so that's the formula for the friction force. And in your case, your normal force is equal to the mg. So you have mu times mg, and that is equal to mu is 0.2, mass is 25, and g is 10. So that gives me 50 newtons. For the next question, they say that a force of 24 kilogram is applied to a given mass and accelerated at 4 meters per second squared. The same force is applied to 1/6 as great mass would produce an acceleration of. So you have the force applied and equals to ma. So the force that they give you is 24 and equals to mass times acceleration they give you 4. So the mass of this object, let's call it first object, is equal to 6 kilogram. Then the next question, or the question that they actually ask you, if the force that is applied to, if this same force is applied to 1/6 of the mass of the first block, so the same force is applied, but the mass is 1/6. 1/6 of 6 is 1. So what would be the acceleration? The acceleration would be 24 meters per second squared. In this question, the last questions for this video, I have two masses connected as shown with their acceleration and tension. You have to find what their acceleration and tension in the rope is. So the mass m1 is given 5 kilograms. So I'm going to say the forces acting on this mass is the force of gravity. So I'm going to say m1g, and the tension force up. And the force acting on the second one is m2g, the force of gravity, and the tension up is up. And the tension is exactly the same because it's the rope, so no matter where you look in the rope does not know who is pulling it where. It just knows there's tension in the rope. So for after that, because one mass is heavier than the other, and it's the m1 is heavier, there is going to be acceleration. So I'm going to say acceleration is this way on this mass, and acceleration is this way on that mass. And then I have to write the net force for the first mass and net force for the second mass. So F net for the first one is equal to ma, so that's what I'm going to be using right now. So for the first mass, I have tension is up and m1g is down, and that is equal to negative ma because acceleration is down for the first mass. For the second mass, I have tension is up and m2 is g is down, so it's negative, but the acceleration is up, so that is m2a up. I have the system of two equations, so I can solve both of them for t and then set them equal to each other. So I have t here is equal to m1g minus m1a, and t here is equal to m2g plus m2a. And then after I set these two guys equal to each other, tension is equal to tension. So I wrote two equations for each mass, and then I have a system of two equations with two unknowns. I do not know what tension is, I do not know what acceleration is, so I'm solving for tension and acceleration. So if I set them both equal to each other, and then I move my mass with acceleration to this side and no acceleration to the other side, I'm going to have this expression. And I also factored out a from this side, so I have a out. Now if I want to solve for a, I'm going to have this. Now I'm going to plug in my numbers, so m1g and m2g divided by m1 plus m2, 2.5 meters per second squared. So I found acceleration. Now to find the tension, I have to plug it in into one of my tensions. So I'm going to plug in into the first equation, and tension is equal to m1g minus m1a. So m1g is 50 because it's 5 times 10, minus m2, which is 5 times 2.5, which is 12.5. So 50 minus 12.5 gives me 37.5 newtons. So I found the tension in the rope and the acceleration of these two masses. There are a few more questions like this online, so you want to practice and check if you can get the same answers for the other ones, to make sure that you can do them without my help. And that will be it for our Dynamics 3 video. So if you have ever questions on any of the topics that we're learning, please email me and let me know which ones you would like me to make videos. It takes me about an hour, 2 hours, sometimes 3 hours to make this video. So make sure that you let me know. Thank you, and see you next time.